All right, this video is going to be about properties of logarithms. So just to recall that there are three properties of logarithms that we need to look at. So let's say that the first one is called log of a. Uh, let's do m times n. This is going to equal as log base a of m plus log base a of n. So what this is saying is that our first property of logarithms is saying that if we are multiplying two numbers with a log base a, this is going to be addition. So we can kind of say that this is what we call the product property of logs. This is what we call the product property of logs. Product, remember, is a multiplication. Let's say that m and n are two expressions, two terms. So we can say that m and n are two terms, numbers, etc. It can be anything, but they're being multiplied with a log base a. A can be anything. So I'm hoping that you get to see that multiplication becomes addition. If you are questioning that a little bit, think about when we did exponents, when we had a to the m times a to the n. Remember when we did exponents, when you are multiplying exponents of the same base, we're going to take their powers or exponents, and we are going to add them. So this is going to be a to the m plus n. Okay, step two, or property two. This is what we call the quotient. So the quotient rule of log, or maybe the quotient property, I guess we can call that, because it is a property. You can call it a rule if you like. But the quotient property of logs says that, well, if I take my log, my log of some base, and I take my m and divide it by n, that's saying that, well, I have log of a of m minus log a of n. What I want you to think about here is when we did exponents and we are dividing exponents, we are going to subtract the top minus the bottom. So it's going to go a m minus n. All right. Step three, or property three, this is called the power property of logs. And what this is, it's called the power, which is because it's like an exponent. So you might want to think about like an exponent. Okay, an exponent here. So this is kind of how it goes. It's log of base a to the m raised to the r. Now, what the power property says that I'm going to take my r, or maybe my exponent, and that exponent says I'm going to come in front. So the exponent says I'm going to come in front. And then this is going to be log of a to the m. So the exponent says I get to come in front. And I'm hoping that kind of makes a little bit sense with the three properties here. So we have the quotient, or sorry, the product property, quotient, and the power property. All right, so let's do some examples with these and kind of keep these in our mind. So if we do this, and let's make a couple of examples here. So example, Says that, well, if we have this, let's do log base A to the 25 times x. So log base A, 25 times x. Now, I don't want you to get confused with this, but another way you can see this, maybe this is 25x. It's the same thing. But it is a product. This is a product. There is a multiplication. And I just want you to understand that there is a multiplication right in the middle. So when you see a number and times it by a variable, so a number times a variable, it's a multiplication. So we can use the property of product property, or the product property of this, and say, okay, well, we can rewrite this as log a 25 plus log a x. We can't really do anything here because we don't know what a is. So we have to just leave it just like that. So we can't do anything else. So let's do some more examples that involve a little bit more problem solving. So why don't we do an ln? Let's do an ln of x over e to the x. Now, if we have this property, we want to kind of question this. We want to see what operation. I think there's actually what operation is holding this together? What operation is holding this together? Now, what I mean by operation, that means positive, negative, dividing, and multiplication. Those are our 4 basic operations. So looking at this one, what is holding this together? If you say division, you are correct. And why is it division? Because there's a division sign. So now we're going to go back to our rules. And we're going to think, okay, it looks like we have something like this happen. We have a quotient. So that's going to be subtraction. So we're going to write this as ln, natural log of x minus natural log of e to the x. Now, we can go a little further, right? Natural log of x, we have to make sure that we just leave it. We can't do anything about it. However, we have natural log and e to the x. Now, remember that e and natural log are inverses. They are inverses. They cancel each other out. So we can say that this can actually be equal to 1. So 1. Why is it 1? Why is it 1? Because remember, if you look at the graphs, this requires you to look a little bit about the graphs. This is natural log, and e is actually like this. So they kind of switch places. So it's just 1. Okay. And let's look at a couple more examples here. Why don't we do something kind of crazy here? So why don't we do ln of x to the third plus 1 equals 8. This one seems to be kind of confusing because if we look at our rules, we have the product property, which is this. That's inside. Wait a second. This is outside. This is inside. This problem does not match any one of our properties. So what do we do? So we don't know. It doesn't match any properties. Well, that's okay. That means it's not going to follow a property. So what you're going to have to do when you see log base this, you can actually just say, okay, I'm just going to go ahead and kind of get this to be a little bit more solved. So I might just say, okay, I'm going to put an e here and do an e here. It doesn't require a property at all. but we can solve still. We can solve. So we can raise e to both sides. Why e to both sides? Because e and ln are opposites. Remember, these are opposites. Ln and e are opposites. They're going to cancel each other out. So if you raise e to the both sides, that's saying that this whole thing is actually going to become all of this to the base e. Now, if you do this, this says I get to cancel out. The stuff that's inside says I get to come downstairs without the other stuff to it. But on this side, I'm going to have e to the raised to the 8. E raised to the 8. Now, I don't care what that is. But what I'm going to do is start to solve this a little bit. So I'm actually going to do some work here. Maybe I can try this, have e to the 8 minus 1. And now you're probably thinking, how can I get the x by itself? Well, if this is the third power, you can take the cube root, and you can take the cube root. Because remember, if you had x to the third, if you take the cube root of it, that's just x. It's kind of like when you take the square root of something. It's kind of like when you take the square root of something. So if you take this x squared, well, to get rid of that, you're going to take the square root of that, which gives you x. So this right here is just going to be e to the 8 minus 1 with that. So that's really it. So you can't do anything else to that. You can put that in a calculator if you like to, but you don't really need to, because a lot of testing just says use the exact. That is exact. That's not an approximation. It's an exact value, not an approximation. Okay. All right. A couple more here. So what if I have e to the x, or sorry, example. Let's make this a little bit more interesting. What if I had natural log of x plus 6 minus ln x minus 4? So here we go. Now think back to your properties. So going back to these properties again. I have multiplication, I have a quotient, and I have a power. Do any of these fill into those properties? Now I want you to understand this. When I write these properties, there's an equal sign here. So that means I can go this way or I can go this way. So I can go this way or this way. So if I see something like this, I might go this way. If on this one, this are equal, if I see something like this, I might have to go back this way. If I see something like this, I might have to go back that way. So that means you can kind of go either or. So you have to kind of be be kind of clever here and actually look at our problem and see what you're trying to accomplish. Now this has ln with some stuff on the side, and it is a minus. So you're probably thinking, okay, I know that the quotient property has a minus in it. So maybe I need to go backwards. So I need to go backwards. So maybe we need to condense. We need to condense down. So we need to make smaller. So we might need to take this into one logarithm, or natural log. And that's what we have to do. So we're going to go ln, parenthesis. This is going to go on top, all over x minus 4. So remember, this goes on top, this goes on the bottom. And you have actually, really, that's all you can really do, because the directions are just maybe put this together. Can we do some more? Well, maybe we can do a similar one to this. So let's do example, and let's do a similar one to this. So maybe let's do ln of x on this side, but let's make this equal to ln x plus 6 minus ln x minus 4. Now, look at the difference between this one and this one. This one really doesn't really specify. This might just say simplify. Well, that's what we can do. That's the only answer. This one has an equal sign. So it looks like we can do a little solving with this one. So this one's a solve. So if we do this carefully, they're both natural logs, which is good. Now, according to this right here, we just done that. So why don't we put that in that form there? So go ln x plus 6 over x minus 4. That's that one. But then we have this natural log on this side. So we're just going to rewrite this natural log. Well, now we're kind of debating. We need to stall. We need to solve this. We need to solve because we have an equal sign. Now we're thinking, what can we do? I have two natural logs that are equal. So maybe in my mind, I'm thinking, okay, well, if two natural logs are equal, that means that this can escape and the stuff inside can escape as well. Hey, look at that, because, I should just say, because natural log of x equals natural log of x. They're equal. So that means they're equal. We can say that x equals x that are inside. Okay, that's the only reason that this can work, because we have two natural logs. So the stuff inside can be equal. Now you're probably thinking, okay, what am I doing now with all this? Well, this is just simple algebra. So what you could do, you could kind of put a 1 right there, make it a fraction, and then do what we call cross multiply. So maybe a cross product. So you can go ahead and multiply by cross multiplying. Cross product's another way. This is actually called product of the extremes, but that's a more sophisticated math term. So here we go. Let's do this. So that's 1 times x plus 6 equals x times x minus 4 if you cross multiply. Hope that you get to see that if you cross multiply. Now, be careful distributing. So that's just that. This is x squared. This is 4x. Well, it looks like we have what we call a quadratic. Let me change this. Quadratic. And so get everything equal to one side equal to 0. Let's make this side equal to 0. I always like to keep the x squared positive. It's just the way I work. So we're going to take all this and move it over here. So that's still going to be x squared. This, if we take this over, that should be 5x. And if we take the 6 over, that should be negative 6. Now, this looks like maybe a diamond method of factoring. So if we take a little diamond method like this and negative 6, negative 5, I do believe that this is 1 and 6, and I do believe that negative 6. So this is a 1, so we don't need to do the bonus method. So here we go. Here's our factors. So it's going to be x plus 1 and x minus 6. Now, according to this, you're going to make this equal to 0. Okay? Because that's called the zero product. Zero product property. Now remember that this is one factor equal to 0. This is another factor equal to 0. So x plus 1 equals 0. And x minus 6 equal to 0. Now you get to finish this up. And I'm hoping that you're thinking about negative 1. And this should be 6. Okay. We have to be careful here. I know that both of these two are possible answers, but we have to think about the domain. Now, the domain of a law, an ln, is it cannot be negative. So what we're going to have, one, is what we call an extraneous answer. extraneous answer. So really, -1 can't work. So this is our answer here because this is a solution for the Ln. Okay, it's a remember that domain. Domain for Ln is 0 to positive infinity for Ln. Be careful with that. Okay, so get through a couple more examples here. Hopefully that this is helping a little bit, kind of finding. I kind of want to help you do some more with Ln. So let me kind of get some here. What if I had log base 5 and maybe I had 25? Let's do another one here. Maybe we can do, let's kind of make this a little bit harder. So what about this? 5, and let's make this the square root of x and 5. So we have two problems here. Now this one, you're probably thinking, I can do this. I can do this. I know that 5 to what power gives me 25. That's awesome. But let's see if we can just break it down a little bit. So this is going to be log of 5 plus log 5 of 5. Now remember, this is a product. This is a product, 25. 25, that's 5 times 5. So log base 5 to the 5th power is what? Log base 5 to the 5th power. Isn't that 1? And then you have 1. So what's the answer? 2. And you understand that this part is 5 squared. So there you go. Remember, this is actually a nice property. Log base 5 to the 5th power is 1. Why? Because remember, there's a 1 right here. There's a 1 right here. How do you know that's a 1? Isn't it 5 to the power of 1, 5? So this is 1, this is 1. Hey, I get 2. But I know that 5 squared is 25. Done. Hope that made a little bit more sense on that one. Now let's look at this guy right here and say, okay, I have a quotient. I have a quotient, so here's what I'm thinking about. Here's my quotient rule. I have a fraction, so I'm going to go ahead and rewrite it as a minus. So here we go. I have log of 5 square root of x minus log 5 of 5. Right, just like that. It's a minus. Now, what do we do? Okay, here's the plan. This part right here needs to be rewritten because I don't know that the square root of x is, remember, x to the 1/2. So I don't know if you know that square root of x is actually x to the 1/2. Well, that's a power. So this is a power. Remember what powers do? The powers say, hey, I get to go in front. So the powers say, I get to go in front. That's really what we need to do here. We need to make sure that this becomes a power because we need to kind of simplify this as much as we can. So let's rewrite this as log 5, but we're going to go x to the 1/2 minus log base 5 of 5. Now, that 1/2 says, I'm a power. I'm a power. I'm a power. So I'm going to go in front. So that's going to be 1/2 log 5 of x. Now, do you remember what this is going to be? Isn't that just 1? And really, that's all you really can do. You can't do anything else to this one because there's nothing really we can do, but we need to kind of make sure that there's no radicals or anything like that. Hoping that this is making a little bit more sense. Let's do a couple more here. So example, let's do something like, what if we had 2 to the x equals 5. And now we're thinking, okay, what am I going to do here? Well, remember, you are solve. You're solving. You need to solve for x. Okay, you need to solve for x. X is right there. Now you're probably thinking, okay, the bases, these two bases are not the same. So you might be thinking, well, I'm stuck. I am stuck here. What can I do? Here's what you can do. As long as you do something to this side and this side, you can actually make this work. So if you're sitting here going, well, I don't really know what to do here. Well, take a shot in the dark here. Why don't we put L into both sides? Why am I doing that? Because I'm trying to make this a little bit easier to solve for X. So I'm going to put L into both sides. So L in to both sides. And I'm just trying something. I'm just trying something because I know what Ln does. And this is exponential. So if I put an Ln, what do I have? Well, this is what I become. Here's what I come. I have Ln 2 to the x. This side's going to be Ln of 5. Okay, well, does that make it better? I guess it makes it okay. So now you're thinking about what can we do? Well, I'm thinking I kind of have an idea what happens here because if we look about our power function back here, if we look at our power function, remember this doesn't have to be log. This could be ln. It's the same thing. So it doesn't always have to be lg. It could be ln. So what's going to happen is, well, maybe that x is a power. It can come up front. Now what? Well, we're solving for x. So if this power can come in front, we have this. Well, if we were solving for x, isn't this x times that? So why don't we go ahead and divide? Why don't we go ahead and divide this by ln2 and this by ln2? So that would take care of that. And what we would have is x on this side and that guy there. Hopefully that made a little bit more sense with that question. I would be very careful with ln because it is a good problem here. Okay, this is the last problem. It's going to be kind of difficult here, but difficult's good. We need to be a little bit challenging. So here we go. 5 to the x minus 2 is equal to 3x plus 2. Now, I don't know if you realize that. Are we really using these properties? Yes, we are. We're just not using them all the time. We're using them because maybe we have problems like this or problems like this that we need to kind of go into a certain motion. So we're not always using these properties, but these properties are just a way to solve some logarithms. And especially for something like this, well, this looks like, well, what can we do? Well, we're solving for x, and maybe we can try, well, why don't we raise both sides to be the L? So why don't we put L in on both sides? And the reason we're doing that is because we're trying something here. We have an exponential ln. Let's try something and see what happens. So if you do ln, that's going to be ln of 5x minus 2 equals ln of 3x plus 2. Remember, this is all going to be that. Now, I don't know if you notice this or not, but we are using this property. We are using this property a lot. So we are referring back to these. We need to kind of see what one. So we're looking at a power function. And I don't know if you ever see that. Here's your powers. Here's your powers. Okay, now take this power and move it in front. Because according to that, you can do that. So that's ln of 5. Hey, look at that. That looks kind of nice. Equals 3x plus 2 ln of 3. All right. And if you really want to, you might want to put parentheses around these because you don't get them mixed up. Sometimes that happens. All right, now what? Well, looks like we're going to have to do a little distributed property. Yeah, we're solving for x. This looks kind of terrible, but it's okay. Here we go. So it looks like this is a distributed property. So we're going to distribute this to each thing. So we're going to go 3x ln of 3 plus 2 ln of 3. All we're doing is taking this and going here and going here. We're distributing because that is a number. That is a number. This right here is a number. Now, can we do the same thing here? Of course we can. This is going to be x ln of 5 minus 2 ln of 5. So we're taking this and distributing that. Remember, that's a number as well. This is also a number. All right, we kind of made it almost look worse. We actually haven't. It actually looks, but it's going to work. All right, what are we looking for? We are looking for this guy and this guy. So do we have any ideas how we're going to do this? Well, this is kind of like going back to solving equations. So how do we solve equations? Well, we got to combine like terms. So let's combine these x's together. Remember, this part and this part are together. We can't break that apart, but we can move it to either side. So let's go ahead and maybe get these together. So I don't know, maybe we can move this one over here. Doesn't matter. So let's move this over here. Remember, here's an equal sign. So you got to be careful that equal sign. You might want to put a little line down here to kind of keep it kind of organized. So we're going to keep that over. So we have x ln 5 minus L in 5. Okay. Now at the same time, can we take this one and move it on that side? So let's move these two over. I'll move this one over and mask that. So this is going to be 2 ln of 5 plus 2 ln of 3. Well, look what we have here. X's are on this side, numbers are on this side. Can we actually keep going? Yes, we can. So we kind of made it worse almost, right? But it's not actually. It's going to work. All right. We are going to solve for x. So why don't we do a factor? So let's factor in x out. We factor in x out. What's left over? Ln of 5 minus Ln of 3. Oh, make sure that 3 is in there. Okay, we factor out an x. Why do you want to factor out it? Because we want to solve for it. This side says, we can't, no, by the way, you cannot combine these. You cannot combine these because they have to be the same number. So here we go. This is going to be 2 ln of 5 plus 2 ln of 3. Now what? Well, this is still an equation. You have an x here. So you're going to take all this junk and you're going to take this, and you're going to put it over here. That says I get to go bye-bye. And there you go. Here's your answer there. That was a nice problem. But they get a little bit longer and a little bit more difficult as you climb up the math ladder. But hopefully this helped a little bit. Please make sure that you go back to these properties and have these in your head. Remember, these can be either or, either or, either or. Hopefully that helped, and I will see you on the next video.